We will be doing one machine learning projects in R. In this project, we'll find the price of the house. Basically, we are taking the housing data sets, and this data set can be available in the Kaggle. So I'll in the descriptions I'll share the link of the data sets and also all the commands that I performed for prediction of the house price. So basically I am using the R code, and first we have to open the R console, R studio. Okay, now we'll be doing all the steps for building the regression model for prediction of the house prices, and this data set is of the Ames, Iowa houses. So I'll be showing all the steps that are essential for building the linear regression model, and from that we can predict the prices of the houses, and we'll be building a model and see how this model performs. So first step, we need to import the required libraries. So in the R, for importing the libraries, we need to give the command library initially. First we need to install the packages. We need to import all the libraries. So I have already installed the libraries deployer. So if you haven't installed the library deployer, first you need to first install the packages. You can basically do it from the command install.packages, and inside the packages you can give the deployer, but I have already installed the deployer, so I am only importing the required libraries. So for that one I will be giving library deployer. You can see over here. So I have employed the library deployer. Then I will be importing the ggplot2. Then I will be importing the option -999, and I'll tell what all the commands will do later. Now first I will insert all these required libraries. Then I'll install the package ggallery, and also the card tools, and I will install the matrix, install that package matrix. Then I'll import the library matrix. Now I have installed all the required libraries. Now we'll be loading the data sets in the R Studio. First, let us give me a brief introduction about these libraries, what these libraries usually do. So the library deployer, this library deployer is a grammar of data manipulations, providing a consistent set of verbs that helps to solve the most common data manipulation challenges. And to avoid all the scientific notation options, I have given the -999, and this ggplot2 is basically for all the charts that will be performing. This card tools also basically a library need for splitting our data sample. Later we will perform this one. For this card tool is basically needed for the splitting the data sample, and for doing the random sampling also. And this one matrix library is usually needed for calculating the root mean square error. So now we will be loading our data sets. For loading the data set, first we need to set the our working directory, so that we can directly import our data sets in the R Studio. For that one, we have to give the command set wd set working directory, and inside the these functions we can give the path. So first we'll set our working directory. Now after the setting the working directory, we'll import the our our CSV file, our data sets, and the name of our data set is IMS housing. For that one, we need to give the command read the CSV file, which will read our CSV file. Now our data has been imported. Now we'll see the our top 5 rows of our data, how the data set looks like. So for that one, we can give the command head, and inside the head we can give our data frame name sales. Okay, we have for this data set we have given the data frame name sales over here. So basically these data sets you can see over here is a big data set. So like it is showing all the 5 rows of the data set, but it has many columns, so that's why in my screen it is showing little in the little space we have in the R Studio, so it is a little bit congested one, but never mind, we'll perform, and we'll see this one later also. You can see this one later also, so no problem for that one. So for right now we'll be moving ahead. So after importing the after loading our data sets, now we'll in the third steps we'll check the structure of data sets. How is our structure of data sets? So for that one we can give the functions str, and inside the functions we can pass our data sets. So let's perform that one. So we can see that so it is very hard for the data sets to show everything, because the data set has many variables. So we can see that our data sets has 2930 observations and 82 variables. So on the basis of these variables we will predict the price of the houses, and first we will build the regression models and see how our model is performing, and so that we can deploy in the production also later. First we need to build our model, right? So these are the structure of our data sets, and the data sets it basically it is showing that the data type of our data sets, like you can see that order has in data type, PID has in data type, area has in data type, so some has a character, and this price we are predicting the price of the houses. So this is our target variable over here. So now we will be performing we will see how our sales data sets, and if there are any null values in the sales data set. So for that one first we'll check if there is any null values in the sales our data sets. So for that one we can give the is.na functions for checking the null of our data sets, null value of data sets. What null value basically is that if there is any missing value, then it is said that it has null value. Null value means missing data sets. So we can for that one we can give the command sort, and sort and column sums functions, and inside that we can give column sums. What it basically do is for all the columns it will combine, and like if there is any missing value, then it will show that that particular column has that missing value. So we can from that command we can see that this order has 0 missing value, PID has 0 missing value, area has 0 missing value, right? So for all the 82 variables it is showing the missing values, right? So you can see in the bottom that some has one missing value, some has 2, some has 79, some has 159, some has 29, 117 also. So what this sort will do is that it will sort on the basis of the null values. First it is showing the variables which has 0 null values, then on the basis of increasing order, then 1, then 2, then 3. So on the basis of increasing order, it is showing the null values as column wise. So now we will see the null values of this garage area. Let's see. So this garage area has one null value. So we can check the null values of individual variables also. For that one, we can give the simple command like some functions, and inside that one we can give the is.na, and it will check the if there is any null values inside the any variables. So sales is our data frame, and inside the data frame we are checking for the column garage area. So it is saying that it has one null values. Basically we have already performed for all the columns, but like if you want to do individually also, then we can do like this. So for that one, basically why I'm doing for this garage area is that we'll be using this garage area for building our multiple linear regression model. So for that we need to replace all the null values with their its mean values, this column mean values. So basically this garage area has one null value, so we'll be replacing this null values with its mean values. So we can give the command like if there is any null values in the garage area, means in this variable, then it will be replaced with its mean value. Over here we can see that first let us perform this command, then we'll see. Okay, so now then for another variable also we will be doing same kind of things, like first we will be checking the null value for mentioned binary area also. Let's perform that one. So it is showing that mentioned binary area has 23 null values, so replacing those null values with its mean values. And now we have replaced the null values of the garage area and mentioned area with its mean value. So now there should not be any mean null values, right? So basically like we'll check whether it contain any null values or not. So basically we can give this command for these two variables. So now we can see that there is no null values in the garage area and mentioned binary area. So guys, I'll be giving all these commands that I performed in the link below. So you can check and play with these commands later. Why I'm converting these null values with the mean values, that because we need those variables. Like there are other variables also which has null values, but these variables are not that much important for predicting the price of the houses. So I'm not concerned with the other variables, like they are not that much important for predicting the price of the house. So now in the fourth step we'll check the summary. For that one we'll give the summary sales command. I can increase this screen size, but this okay for right now. Okay, what summary function does is that for all the numerical variables it will show the summary statistics. So here you can see that for the order it is giving the mean order column, it is giving its mean value is 1 and max value is 2930, and its median was 1465 and mean was 1465. For the price also it is given like that. So basically the mean value and max value, the range of mean value and max value is different for different variables, right? There was a wide range of distribution. But what is the benefit of using the linear regression model is that linear regression model is very powerful model. So we can do like feature scaling also, like converting all the mean values to mean and max values from 0 to 1 by doing the standardization also. But for the regression model, that regression model is very powerful model. So like it will sort by itself. But if the model, we'll see later that if the model is not performing well, then we can do the standardization or normalization also. Right now we're not doing anything. So you can see that in the price, the minimum value of the price of the houses was 12,789, and max was 755,000, right? So its mean was 180 and median was like 160,000. So we can see that there was little difference between the mean and median prices. You can see over here. So it shows that if the mean and median value is little is more different, then we can say that this data set is not normally distributed, right? So there may be some extreme values, so that this mean and median is not quite similar. Your mean is smaller than its median. So now we'll move ahead. We'll give the function for categorical variable. We can for this summary we will only show the numerical variable statistics, right? So you can see over here for the character variable, it is not showing anything, right? So it's for the land slope, it is not giving anything for utilities, because these all the variables are character variables. For the categorical variables, we can use the table commands. So I'm basically in these steps I'm performing the summary functions for only the certain variables that I think important for the our model. So I'm only specifying the certain variables like price, area, mention area, garage area, and first floor square surface area. Basically this is, I think, this for first floor area, I think. So now we'll see some of the categorical variables and see how these variables are. For that, for seeing the categorical variables, we can give the command table summary for the numerical variable, and for the categorical variable we can give the command table. So first we'll see for the overall quality of the house. So let's perform that one. See, the overall quality of the house ranges from minimum value was from 4 and 1, and maximum value was 10. So basically what it is saying is that there are 31 number of houses among the all houses which quality was 10. 10 means with maximum quality, right? Maximum is considered to be a good house with a good quality, right? And 1 means the minimum quality. So again we can do for this built year, external quality, and neighbor. See, these all are the categorical variables. So we have to use the table functions. So we can see that for the neighborhood, with the different neighborhood, the distribution of houses were different for the different neighborhood, and for the external quality also. So for excellent it was 107, and for the least excellent it was like 799, like this kind of things. Now we'll see the histogram, so that it will be more clear from the histogram chart to see the distribution of the different variables. First we'll see the histogram of the price of the houses. For that we can give the command hist, and inside that one we can pass the variables for which we are performing the histograms. Other we can like change ourselves, like over here, and we are giving the red color for our diagram, and break 50 means like it will be divided into the 50 parts. So first let us perform this one. So we can see that This is the distribution of the prices of the house. So before also we saw that in the summary statistics, let me go see over here, our mean value was a little higher than this median value, right? Our mean value is a little higher, so we can see that this is not perfectly normally distributed, right? Over here also there are some extreme values. We can zoom, I think, from here. Zoom. Yeah, so we can see that in the right side, like some of the houses have more prices over here, but then their number are little lesser. So now we'll see the count. We'll see we'll give the one count variable and see same. We'll do the same operation for the other column, other features like a year built, and we'll be performing the bar chart for that one. And let's see. So when we see the comparison of the year built of the houses, it is seen that there were basically less number of houses that were built in like initial years 1872, but slowly increasing or decreasing, and the maximum house were built around 2000 and 2002 and 3, right, over here. So basically what we are seeing is we are like from this all the charts we are seeing the how the data is distributed. Now we see for the condition of the houses. For that we are performing the bar chart. So what we are doing is for the bar plot we can give the table functions. Inside the table functions we can give our column name. Then this main is the our this bar chart heading, like main, this one. This is title. This for the x-axis we are giving the name condition of the houses, and for the y-axis we are giving the name of the number of houses, and this the color of the chart we are giving the values. We can all manipulate this all thing, right? So this is not the main issue. What is the main thing is that we want to see the distribution of the houses, the condition of houses. We can see that on an average the condition of houses were good, right? Because the condition of houses from 5 to 8 a little more than the condition 1, 2, 3 and 4. So it shows that our data set has the good conditions of the houses. Now we'll see the prices per neighborhood, like if the prices are determined per neighborhood or not. So let's go. So from our dot plot, you can see that the prices of house ranges from according to the neighborhood, right? So this neighborhood, Meadow, has basically list price, right? So, and like we can see in the graph that the prices of the houses or maximum at for this neighborhood Stone, and for another one, and for lesser for this one. So I have all sorted according to the price of the house, so it is more visually appealing, right? So you can have distinct, we can see the distinct prices. So now we can see the external quality of the houses also. Let's see how the data are distributed for external quality of the houses. Like for the external quality of the houses, it is seen that which external quality of house determine the prices. It means like for the excellent quality of the external quality of the houses, the price is more, right? For good, it is a little bit lesser than external excellent quality, but good than others one, right? So like, and one thing is that for this all the charts I am taking its median value, median price of the houses, then this mean, because in our data sets like, let me run that one prices distribution again, so it will be more clear. What is the price, summary price? Okay, there we go. See, while we were checking at the price of the houses, the mean and median prices were different, right? So mean was more. That means the house were not normally distributed. What happens is that the mean value is greatly affected by the extreme values. So like, so if some values have some of the houses, some of the few houses have extreme high prices, then it will, that mean value will be affected, right? So basically, it's not good idea to check to take the mean value for these conditions. So median will be the perfect value. So I have taken the median value, because since median value will divide the data into two equal halves, right? So for calculating this kind of variables, which data are not normally distributed, then we can go for the median value also and see how it performs, right? So these are all like visualization part. I think we have seen for the external quality and quality of the houses, and for the neighborhood also, and for the built year also. So we'll move forward, I think. Now we'll see. Now we have visually seen the how the these mean different variables affect the price of the houses, but we'll see through the correlation correlation coefficient also, so that it will be more clear. So for that one, for performing the correlation functions basically show the correlation between the target variables or price of the house with the different variables. So for that one, we'll only select our numerical variables. And we have performed the heat map through the ggcore library we have imported earlier. Let us zoom this one. I did not zoom. Okay, fine. So we can see that for all the numerical variables, we have performed the heat map. So what it is saying is that for the different variables, it has different correlations. So we can compare from this one. The variables which are highly correlated have red color, right? So, and which are negatively correlated has blue color. So one thing we can notice from this one is that this one is darkly blue, right? So it means that this one, year sold and order, is highly negatively correlated, right? So basically you can see the correlation of different variables with one another, right? So for now we'll move ahead and select those features that are highly correlated with our target variable price, right? For since we need to determine the price of the houses on the basis of different variables, we'll be targeting more on the correlation of different variables to the price of the house, right? So now we'll see the correlation of different variables correlation coefficient of different variables with the prices of the house. So in the first command, I'm seeing the correlation with the enclosed post with the price of the house, and second with the PID, third with the overall quality, fourth with the area of the house with the price. Let us run, and then I'll go more deeper, then it will be easier for me. Okay, so you can see that while giving the correlation command, so correlation, for popping the correlation in the R, we can give the command cor function, and inside that one we can pass the two variables and compare the correlation between the two variables. So we are basically performing the correlation between the price and other features, right? So for our this first for our first we are popping the correlation of the price and income sport, so it was negatively correlated. So you can see that for PID also it is negatively correlated. For overall quality it is positively correlated. For the area it is positively correlated. First floor square feet also positively correlated, 0.6, right? It is highly correlated, right? So correlation correlation coefficient ranges from -1 to 1, right? So around 0.5 we think that it is like highly correlated, right? So for area also it has good correlations. So basically what is your build also, it has 0.5 0.6 so I mentioned banner area also it has around 0.5. so from the correlation we can confirm that these the correlated the variables which have high correlations, we can say that they are highly they can determine the price of the house. So basically like those correlations, those value which have high correlations will like take those value to those variables to build our model. Now let me go in the next okay, so now in this one in this graph we can see that in this heat map we can see that we have taken all the variables, right, numerical variables. So now we'll select those variables which is highly correlated with the price of the house. So that for that one we'll selecting the specific variables. Okay, first we will see that those variables which has positively correlated and and these two are negatively correlated with the price of the house. Here you see with the price of the houses these two variables are negatively correlated, right? This PID and enclosed posts. So it basically will not select this one also, but I'm just showing. In step 5 now we will be splitting our data into training and test set. So so for that one we'll give the sample.split function. What it does is that it will sample all the form of data set. It will randomly sample the different rows and split our data set into 70% and 30% for the test set, 70% for the train set and 30% for the test sets. And we are giving seed 2 so that this seed to what this seed to seed function does is that if you pass any number for the seed function, then whenever we run the same command, then it will give the same result for that only. So like we're sampling our data sets and splitting into 70%. We have given the object name, variable name sample. And then for our trained data sets, we are subsetting these samples. These samples equals true means we are subsetting the samples into 70%, and for the test we are like subsetting into 30%. So now when we see the dimension of the train and test, it will be more clear. So for the dimension of the train dataset and test datasets, there are 2035 rows for the train, and for the test there will be 895 rows. Now we'll separate the test level from the test datasets. For that one, I have given the variable name test level, and we are selecting all the rows, but only the first let us like perform this one. Okay, so basically what we are doing is we are selecting only the prices of the house from the test data as our test level. So you can see from here. So we are selecting only the price of the price column, which is our test level. This test level is important, like later we'll be comparing the our predicted price of the house with this test level, actual price of the house. So basically we are giving the test level and storing all the price of the house to the variable name test level. So now in the next step we are training our model, and for the training our model will be giving command. You give the function lm. It is quite easy, like it has inbuilt function lm, which will create the linear regression model. So our target variable was price, so we'll be performing we'll be checking the price of the we'll be building the model on the basis of our target variable prices with other variables like overall quality, area, garage area, first floor square feet, dimension area, your build external quality, full bath, and our data is trained. We are basically building the model on the basis of trained data sets, and later we'll we'll build the model and later check without test data sets. So we are selecting only few specific variables, because in the earlier step we have seen that these variables have highly correlation with the price of the house, right? We have seen earlier while doing the correlation function, right? So basically we are taking these variables. So and we can see the summary of our model by giving the summary command. Now we have built our model, a linear regression model. So you can see that our linear regression model has been built, and over here we have given the command earlier, right? This one, this formula, and this has all this is on this model was performed on the basis of overall quality, area, garage area. These are all the columns name. So regression model was created with the lm functions, and lm is a function. This lm is a function, and 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 this lm is a fun used to create the regression model using the variables overall quality, area, first floor square feet, mention area, mention winner area in square feet, garage area, year build, and full bath, right? And this model here, the model the multiple r squared is this r squared value is 0.8, right? 0.8, we can say that 0.83, which states that our model explains 83% variation in the dependent variables, and that means that our the variables we are using for building our model explains the 83% 83% of the variations in the our dependent variable price. So I think it is a quite good model, right? And the adjusted r square, value corrects the r square by penalizing models with a large number of independent variables. So more the independent variables, this one it will be little the value of the adjusted r square will be little less than the multiple this r square, multiple r square. So more will be the variables, like it will show a little less than the adjusted r, this one multiple r squared. So square, and this one this asterisk sign over here is showing that more the asterisk sign, we can we can just think like that. More will be the asterisk sign, more our model has performed well with this these variables. So it is significantly accepted, right? So our significant level was 0 for 3 star. This one we can see over here, this for 5%, for 1%, for 0.1%, and for the 0%. Like we can think like that. If there are more stars, then that model has perform well, or model has built well with these variables. And we can see that, and this was all this all values, this estimated means, like we can see that for the area it is like 54.77 estimated, right? What it means is that if all the variables are set to 0, and if we increased our area by 1 unit, then the price of the house will increase by $54. It is saying like that. And it has for the external quality of the houses, it is a categorical variable, right? So for the categorical variable, the model will build the dummy variables for the categorical variables. For the external quality of the houses was like categorical variable, so it has created the dummy variables. It has four this external quality has 4 features, 4 categories, so it is showing 3, and on the basis of this one external excellent quality, it is showing the estimation. Now I think we can move ahead. Now we have built our model, right? We have like r square was 83, around 83%. So it is a quite good model. So now we'll predict on the test data sets, and see how the accuracy is. So for that one, we have to give the function predict and pass the argument model. Our model, we have built this one model and this test data sets. So let's see how it performs. So this is our predicted price for the test data sets that we have splitted. Like we have order we have splitted 30% for the test data set, right? So for that test data set, it is predicting the prices. Now for all the this data set it is predicting the prices. Now we will compare all the prices with the original price. Now at the another steps, we'll compare the actual price with our predicted price, right? So for that one we can do the plot, so it will be more easier to visualize. So let's do the plot. So this is our test level. So this is the actual price of the houses. So we are seeing in the line graph that this actual price of the house. So it has we have given the red color for these prices of the houses, and the price of the house ranges from this to this, right? So now we'll see the predicted price of the houses in the line graph. For that one, we'll giving the line functions, and inside this we'll be passing our predicted value, and for that one we'll giving the for this line graph for the predicted price we'll giving the blue color, so that we can easily compare. Okay, so now we can see that for this blue color is for the predicted house prices, and for our original house prices it was red, right? So basically around 83% like it is like overlapping, right? So basically the model is performing quite well, right? So this way we can visualize also by using the line graph. So I'll giving all the commands in the link so that you can play with the commands. And for the linear regression model, best way to check the accuracy is by using the root square mean error. So what a root square mean error is that it will subtract our predicted price of the houses with the actual prices, and it will take the mean of all the values, and and it will show us the root mean square error. So let us perform the root square error by giving the command sqrt, and sqrt is root square, and we are checking the root square mean error, and this and predict test level square is our predict is our predicted price minus our test level actual price. So we are doing the subtractions, and then we are squaring it, then we are taking the mean of those errors, and we are basically doing the square root. So to do that, it will give the root mean square error. So we can see that the root square mean error is 30,982, right? So now from that one, what we can conclude is that the weighted average error between the predicted price and actual price in the dataset was 38,000, right? Around 39,000, which is likely a good value given that the average house price of the dataset was 180,000. So the average price of the house was 180,000, right? So in our model it is saying that error was 38,000. So root mean square error, RMSE, we call in short form RMSE, value was quite small, right? So this RMSE value was quite small, which means the model has good enough to predict the future datasets. Thus, while forecasting the numerical datasets, the regression model was the best options, I think. So our model has performed well. So basically by this way we can use the linear regression model for predicting the price of the houses. So in summary, I will be quickly give the overview what we have done in these projects. So let's see. So in the first step, we have imported all the required libraries, right, for the our numerical operations, for our visualizations, for our for removing the scientific notations. We have given the option Cyphen, and for these all libraries are required. And in second steps, we have load our data sets. Basically our data set name is IMS housing, so I have downloaded this from Kaggle, and I will share the link for the data sets in the description also. Then what we did we did the data exploratory analysis. So basically we saw the structure of data sets, other data sets, how many rows and columns. And then basically what we first step we need to do is we need to check the null values of the data set, right, before doing anything. So first step is to see the null values, and we have to replace those null values with the mean values. So basically we are picking only those important variables. Basically there are 82 variables, right? So many different features of the houses, so all are not that much important for predicting the prices of the house. So in the data science, what we need to do is we need to select only some specific features that are really important, so the so that our model will perform well, right? This way we'll build our model in the machine learning, right? So we have checking the summary of the data sets. In the summary, we have checking in the summary what it showed was the mean and maximum prices with the median and mean prices, so that we'll have a nice overview of the distribution of our data set, right? So for the categorical variable, we have used the command table functions, and we also did the exploratory data analysis and see some of the visuals, how the variables are related with the price of the houses. So we have performed the histogram, bar chart, and some dot plot also, right? Then we had seen the correlation of different variables with the prices of the houses, and those variables we have highly strongly correlated. We have selected those features for building our model, right? So we have seen the correlations, then we have split our data set into 70% and 30%, and we have built our model on the basis of important features that are highly correlated, and those features which are shown the strong relationship with the price of the houses, right? And this external quality was the categorical variable, right? Other were numerical. So basically we can play with the different variables while building the model and see how the model performs, right? So in our like I have also tried with different variables, and later I have sorted some few variables, and I have used this I have only used these variables for our final project. So we can see the summary of our model by giving the summary command. We have performed that one also, and we have built the model, and our model was predicting 83%. Our R square value was 83%, which says that our model will describe the 83% variations related to our dependent target variable, price of the houses. And we have perform the line graph to compare the training and predicted and test price of the value, right? So it is in that it is highly like overlapping, right? The blue color was for the predicted prices, and red color was for the test prices. And at last, to check the accuracy in the regression model, will basically use the root mean square error. So our root mean square error was like around 30,000, right? So 30,000 in comparison to the median price of the house was like 180,000, right? So in comparison to the median price of the houses, it is quite low. So that means that our model has good enough to predict the future data sets, and we can deploy this model to predict the price of the house for the future data sets. So friend, I think I have from this project we have built our model and predicted how the model performed for the prices of the house, right? So this way you can use the linear regression model for the numerical data sets. Okay, thank you. I'll be catching with next videos later in the future. Thank you for your time. I think you have learned something from this tutorial. Thank you so much.